Title your notes, Solving Linear Inequalities. Solving Linear Inequalities. Now, on your Cornell notes. Now, as you notice, there's a pattern to how we introduce new concepts, right? We started at the beginning of the year with real numbers. We went into expressions. From there, we went to one variable equations. And then from there, we went to one variable inequalities. From there, we jumped into two variable equations. We got into graphing, solving, and then from there, we got into system of linear equations. Well, now we arrive at linear inequalities. Today, we're going to do solving and graphing. So our objective for today, I can solve and graph linear inequalities. Read together. 1, 2, 3. I can solve and graph linear inequalities. So today we'll get started with this, and then that's going to lead us to systems of linear inequalities. Since we love systems of equations, now we're going to get into systems of linear inequalities. So, what are linear inequalities? In your prayer model, write this down. Linear inequalities. It says a two-variable inequality that represents a region of the coordinate plane. A two-variable inequality that represents a region of the coordinate plane. Okay, what does that look like? Let's find out. A linear inequality looks like this. Negative 2x plus y less than 1. 4x plus 6 greater than negative 2y. Y greater than or equal to 2x plus 1. Or y less than or equal to negative 3. Copy those, please. So let me go over these examples according to the definition. So pens down, eyes up here. It says, a two-variable inequality that represents a region of the coordinate plane. Right now, I'm not going to graph, but I do want you to know what a linear inequality looks like. Let's see. Look at this one. Two-variable inequality. Linear inequalities are two-variable inequalities. See, two variables, inequality, yes. Two variables, inequality, yes. Two variables, inequality, yes. Two variables, inequality, yes. You're saying two variables, yes, right here. Do you guys see that now? Okay. So with that said, if those are examples of linear inequalities, let me show you non-examples. Copy these down, please. X plus 5 equals y. Y equals x squared minus 8. Y equals x cubed. And x over 4 equals 9. Now, I want you to change these two. This one, you're going to write y is less than or equal to x squared minus 8. And this one is y greater than or equal to x cubed. Copy those. Okay, so think about it. If these are linear inequalities, two variable inequalities, okay, all these, why are these not linear inequalities? Think about it. Why are these not? Okay, discuss these with your neighbor, please. Why are those not? The most important thing to remember of linear inequalities, are they have two variables, no exponents greater than 1 on the variables, and no equal signs. No equal signs. Okay, steps. Write these down. These next steps that I'm going to give you are to graph. So today, yes, we are going to be solving. I'm going to show you the solution, but they're mainly to graph the inequality. So copy these down, please. Steps. Step 1, solve for y. Step 2, graph the inequality like a linear equation. Step 3, check a point and shade the solution set. Step 4, state the domain and range of the solution set. So, 4 easy steps for right now, the one that I really want to focus on, or the first part, will be the first 3 steps. And to not start off with graphing, we're going to go ahead and do a couple of checking the point without graphing. We already know how to do those because we did those with linear equations. But I want to get us some practice with linear inequalities. Okay? So, 4 easy steps. Solve for y, graph the inequality like a linear equation, check a point and shade the solution set, and at the end state the domain and range of the solution set. Everybody there? Okay. Example 1. Example 1. Example number 1. Copy this down, please. Example 1A. It says, tell whether the ordered pair is a solution of the inequality. Tell whether the ordered pair is a solution of the inequality. Copy that down. I'm going to show you right now. Example 1A, tell whether the ordered pair is a solution of the inequality. And then they give you the ordered pair is -2, 4, and the inequality is y less than 2x plus 1. Once again, the ordered pair is -2, 4, and the inequality is y less than 2x plus 1. You got 20 seconds to finish. Here it goes. Now, like I mentioned before, we already know how to check these. But we used to do the ones that were linear equations. But it's the same process. Check this out. I write my linear inequality, y less than 2x plus 1. But I need to substitute values, my x value and my y value. So this one goes here, and this one is -2. Bring everything else down. This becomes -4 plus 1. This becomes 4 is less than -3. Let's read it. Is 4 less than -3? No, this is false, so therefore not a solution. Copy that, please. Example 1B. You don't have to copy now the text. You already have the instructions. Just copy example 1B. Here's your ordered pair, 3, 1. In your inequality, y greater than x minus 4. Let's do this one together. Yes. So we're going to substitute values in here. We need our x value and our y value. So therefore, y is 1 greater than 3 minus 4. Therefore, 1 is greater than -1. So is 1 greater than -1? That is true. So we write the point 3, 1 is a solution to the inequality. 10Q. Fairly simple? Okay, I'm going to give you another one. You do the next one. Here it goes. Example 1C. Example 1C. Check to see if 4, 5, this ordered pair, is a solution to y less than x plus 1. Go. Here it goes. We substitute for values x and y. So this is 5 less than 4 plus 1. Is 5 less than 5? No. No, that's false. So therefore not a solution. Is 5 less than 5? No. 5 is equal to 5. Okay, let's do one more. Last one. Example 1D. Last one of these. Copy this. Example 1D. The ordered pair 1, 1. Check and see if it's a solution to y greater than x minus 7. Go. So let's see. 1 greater than 1 minus 7. 1 is greater than negative 6. That is true. So therefore, the point 1, 1 is a solution to the inequality. 10Q. Alright, so get your graph paper in front of you, please. We're going to start with graphing now. Okay, on the big graph paper, here, on the big graph paper at the top left of the big graph paper, copy that example down. Example 2A says, graph the solutions of the linear inequality. Check your answer for y is less than or equal to 2x minus 3. Copy that, please. All right, here we go. In order to graph the solution to this inequality, we're going to start with our process. I gave you guys the 4 steps, right? Step 1, solve for y. Is it solve for y? Yes. Okay. Step 2, graph like if it was an equation, a linear equation. Now, if you can't visualize it, here it goes. Let me show you really quick. Watch. If I was to cover this, and if I was to make that an equation, do you remember how to graph these? Yes, we start with our y-intercept, which is 3, or I'm sorry, negative 3. And then we use the slope. The slope tells us to go 2 steps up, 1 to the right. So everybody, let's plot the points together. We got negative 3, and then we go 2 steps up, 1, 2, 1 to the right, 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 1 to the right. I said just plot the points. You don't need to graph your line yet. All right. So far so good, right? However, this is not an equation, but we do step 2 like if it was an equation. Okay? Didn't we just do that? Yes? So, since we no longer have linear equations, now we have an inequality. Let me show you what the graph looks like of an inequality that has this symbol. It's the symbol is less than or equal to, or it could also have greater than or equal to. My line looks like this. And so you're like, Mr. Q, looks exactly the same as to what we've been doing so far. Yes, but this is where I want to go. Pay attention. Pens down, eyes up here. I want you to see the following. I'm going to show you the graph. This graph is this one, but I'm still not done, but that's partly there. But what if this was different? What if this was like this? What did I just do? So what if your inequality didn't have an equal sign? Let me move this line out of the way. Like I said, you're just paying attention. And I'm going to graph like if this didn't have the equal sign. Check this out. This is what your line's going to look like. Notice the difference? Okay. So, now, the question is, why? Why, when this one has an equal sign, is a solid line, and why is this one dashed when it's not? So let me take you back. Here it goes. Just to clarify for those of you that are still, you have no idea what I'm talking about, here it goes. When we got to graphing inequalities like this, which was not too long ago, let's say I gave you y is greater than 3. To graph this, we start at 3. Does it have an equal sign? No, so it's an open point. Why open point? Because it does not include the 3. And then we graph everything to the right. However, what did we say if it had an equal sign? It's a solid point. It's a solid point, which means it includes that point. So let's look at this. If this does not have an equal sign, it's a dotted line because it does not include all those points. However, since the line or the inequality does have an equal sign, right? That's why it's a solid line. Everybody see that? Make sure you extend the line all the way through. Copy that, please. You don't have to copy the dotted line. Go. So here we go. So we're still not done. We still need to graph the solutions to the inequality. Now, this is where it's going to get a little bit challenging. So focus, please. There you go. Pens down, eyes up here. So before I get started with the graphing part, I just want to make sure you understand what we have in front of us. Everybody look up, please. And every time I ask you to graph, I ask you to extend your line all the way through. Is that correct? So you should have something like this. Here's your coordinate plane. And your equation, your line was graphed, and it goes all the way to the end. Is that correct? Okay. So right now, if you notice, look at your paper. Some of you have your line like this, and it goes all the way from one end to the other end. However, some of you left it really short here or short here. You need to go all the way through. Why? Check this out. And you're saying, what are we looking at, Mr. Q? You guys see this rectangle here? And you see this line? This rectangle? See this line? The same thing? Okay. But the reason I wanted to show you this without the coordinate plane, so that you can see that this rectangle is divided into two sections. With this line divided it into two sections. Section 1 and section 2. You guys see that? And you're saying, let's see, section 1 is from this line and everything that way. Section 2 is from the same line but everything this way. Are we there? Okay. So, are we there so far? All right, so now check this out. To graph the solutions for this inequality, I need some information from here. I need this piece, y less than or equal to, and I need this piece, minus 3. So you're saying, oh, Mr. Q, this looks familiar. If we look up, doesn't this look familiar? Yes. If I was to graph it like this, do you know how to graph this? However, since now we have two variables and two axes, this is what? Y. So let me turn this over so you know what I'm looking at. And do you see that here, our y-axis? Does everybody see that? So we're going to graph that using that y-axis. Here we go. Negative 3 is right here, and it's a solid point. Is that correct? But it says y is less than negative 3. What numbers are less than negative 3? Negative 4, negative 5. All of these, right? Okay. So now, check this out. We started here, and then you said these over here. Is that correct? In what section are all those found? Section 1 or section 2? So therefore, my solution to that inequality are all these points under that line. All of them. So I need to shade everything down here. So shade everything, please. Shading. Like I said, stay with me or some of you are going to miss it. So, we're almost there. All right, so you're saying, Mr. Q, I don't know why we're shading. Well, let me explain it. Here it goes. I showed you the steps as to how to find the solutions to the inequality. But you're saying, but how do I know if I'm right? That's when we check. So check this out. Everybody look up. Pens down. Look up. I'm going to place a point on the shaded region because I'm saying that all these points are a solution. So let's say I'm going to pick, I'll pick this point right here. So you notice that this point is on this section, right? So what is that point in coordinates? 5, 5, 5, 5. Just pay attention. To check, I'm going to see if it's true. What is y? 5. What is x? 5. So this becomes 5 less than or equal to 10 minus 3. What is 10 minus 3? So is 5 less than 7? Yes, that's why this is true. True. That's why this works. And you're saying, so what are you saying, Mr. Q? I can pick any other point and it's going to be true? Yes. Yes, question. Why did we do the y-axis? Look at it. What variable is it? Y. Yeah, so since we're solving for y, we're always going to base it on the y-axis. Yes. And so now, what are we talking about? So if I was to ask you to pick any point over here, you're going to pick a different point. Each person, did I tell you exactly which one to get? No. But did I tell you from what section? Yes. So what am I saying? That all these numbers, all these points are a solution to the inequality. That's why this is known as the solution set. Solution set. All those points are a solution to the inequality. Everybody got it? So what do you think will happen? Everybody look up. What do you think will happen if I was to substitute, let's see, this point right here? Let's see. I'm going to substitute that in here. Y less than or equal to 2x minus 3. That point is what? 1, 1. 1 less than or equal to 2 times 1 minus 3. 1 less than or equal to 2 minus 3. 1 is less than or equal to negative 1. Is 1 less than or equal to negative 1? No, false. That's why these are no solutions. Have you got it? Okay, let's do another one. Example 2b. 2b. Example 2b. Copy this one. You don't need the instructions since you already have them written down. But write example 2b. 5x plus 2y greater than negative 8. Step 1, Ryan. Solve for y. Therefore, we need to get rid of the 5x. Is that correct? Let's do this one together. Minus 5x minus 5x. We got 2y greater than negative 5x minus 8. What's my last step? Divide by 2. Divide by 2. Y is greater than negative 5 over 2x. And this is what? Negative 4. Do you know how to graph this? Yeah, step 2 says graph it like if it was an equation. So where do I start? Negative 4. We place that here. And we use the slope. What does the slope tell us? Down 5 to the right. 1, 2, 3, 4, 5, 1, 2. I think you have space for one more point, right? Now, tell your neighbor what kind of line this is, a solid or a dotted. Okay, I heard dotted. Is that correct? Yeah. Okay, that is true. It's a dotted line. So now, why is it a dotted line? Because it doesn't have the equal sign. Are we there? All right. So now, we want to find out which direction we're going to shade. So let's see. What do I need? If we look up, I need this part, y greater than, and what else do I need? The negative 4. Okay, let's graph this. Y is greater than negative 4. Here's negative 4. What numbers are greater than negative 4? Yeah, what does it say? Y is greater than negative 4. -3, -2. In what section is this at? In this section or this section? So therefore, we're going to shade everything above the line. Everything above the line. Everything. Does everybody see that? Okay. So, for those of you that don't see it, let me show you this without the coordinate plane so you guys can actually visualize it. Here's my line. Let's see, what does it look like? Okay, like this. My line goes like this. What sections do you see? Section 1 and section 2. What's that? How does it what? Because it divides the coordinate plane into 2 sections. Okay. Hold on. Okay, this is section 1, this is section 2. Doesn't matter. All I'm saying is that one section is 1, the other one is 2. There's 2 sections. I understand what you're saying, Bree, that you're saying, how come the answer is on section 2 again? No, it doesn't matter. What I'm trying to show you is that it divides it into 2 sections. So what is the question? Sorry. Oh, why I picked this side? Oh, because it goes with a graph. Check this out. What part of the inequality did we use to find out which way to graph? I used this part and the last part. And this is key. Watch. Let me go over here. This, let's say this, what was the inequality? -4? -3? -4. Okay, let's say this is -4. My inequality is y is greater than -4. So check this out. This is -4 right here, and this is my y-axis. Oh, wow. Okay, so, Bree, here's -4. This says y is greater than -4. What numbers are greater than -4? -3, sorry, -3, -2, what? Everything this way, right? Here it goes. All these. In what section is that found? On this section or this section? Over here, that's why we shade all of these. So now, we're not done. Here it goes. So, now that we shaded our section, let's double check to see if it's true. I pick a point from this section. If we look up to check, let's pick a point from this section. What is the easiest point that you can think of by looking at it? 1, 1, or 0, 0. Either one. So I'm going to pick 0, 0. So let's see. And I'm going to substitute in here. So I got y greater than -5 over 2x minus 4. So this is 0 greater than -5 over 2 times 0 minus 4. This becomes what? 0. So is 0 greater than -4? Yes. True, because this point is on the shaded region. Everybody got it? So, homework for tonight. The homework is found on what page? 368. Numbers 1 through 18 all. Okay, guys, I'm here for tutoring. If not, enjoy your homework. See you guys tomorrow.